Nuclear energy is one of the most effective sources of renewable energy and is one of the best for the environment. It is a way of generating energy without producing greenhouse gas and emitting it into the atmosphere, which helps to reduce pollution. It is around 2 to 3 times cleaner and more effective than solar and wind. France is a place which uses nuclear power highly and is the largest producer of nuclear power. They switched to it in order to conserve their coal, oil, and gas because they had little of it. 72% of their energy comes from nuclear power. France has enhanced safety measures in order to reduce the chance of an incident occurring. Modern reactors are made safer. The heat from the core is made to gradually dissipate from the walls of the vessel where the pressure is applied. Germany is also going renewable, but mainly with solar and wind, and they spend twice as much and are still contributing to the amounts of CO2 going out. France produces 1/10 of the carbon pollution that Germany does. France's nuclear power plants can last 40 to over 80 years, while Germany's solar farms will need to be rebuilt every 25 years. There are relatively low costs associated with nuclear energy. Despite the initial cost, which is incredibly expensive and keeps rising, they aren't that expensive to maintain, and there isn't as much maintenance needed as compared to other sources of energy. Despite the pros of nuclear power in our world today, many places are trying to avoid using it because they believe it may not be worth the risk of a possible explosion or melting of a reactor.
I'm going to be explaining the physics behind the nuclear power plants. So, first, the plutonium or uranium fuel is added into the reactor. The neutrons then collide with the uranium atoms, which splits them in the reactor core, and this causes a chain reaction that is controlled by the control rods that absorb the neutrons. So this equation right here is actually Albert Einstein's equation, and it is E equals m times c squared. So this means that the mass is multiplied by the square of the velocity of light, and it is also known as fission, which is an atom's nucleus that can be split apart. So going back to how the nuclear power plants work, so once the uranium atoms split, they release energy that heats the water to about 520 degrees Fahrenheit. And then the water then turns into steam, and the steam turns the turbine that generates the energy or electricity. So not all nuclear power plants have cooling towers, but some do. So how the cooling towers work is after they generate the energy, the steam is sent through an electric pump. And once the steam gets to the cooling towers, they turn the steam back into water. And then that water is then reused to produce more steam, and then the process just keeps going. But the nuclear power plants that don't have cooling towers, the nuclear waste is stored in pools to cool for many years, and some is moved to above ground concrete casks.
The two main problems people point out about nuclear energy are the expensive upkeep of a nuclear power plant and the potential harm nuclear energy can cause to the environment. Considering that a small nuclear reactor costs about $750 million, it is safe to say that building one of these nuclear power plants is costly. Despite this initial building cost, the price to produce electricity through nuclear energy is relatively cheap. It costs $2.10 per kilowatt hour to generate electricity, which allows these power plants to remain profitable. Yes, they are expensive to build, but relatively cheap to run. The second problem with this renewable energy source is the harm that it can cause on the environment. If done incorrectly, the splitting of a uranium atom could cause great damage to nearby environment. Radiation is terrifying, and it is known to cause a number of problems to the things it comes in contact with. However, if we just take the proper steps in producing and storing this energy, nuclear power plants really wouldn't do as much harm as we think. This method is actually known to produce less CO2 than traditional coal-burning methods. A nuclear power plant produces 12 grams of CO2 per kilowatt hour, while a fossil fuel power station emits 808 more grams of CO2 per kilowatt hour. These low CO2 emissions could do great damage to the high levels of greenhouse gases found in our atmosphere, which is why nuclear energy is one of the most efficient methods of renewable energy sources.
Nuclear energy is a very exciting future, both in terms of physics and in implementations for society. Future nuclear reactors will, instead of fission, use nuclear fusion to function. Nuclear fusion is the combination of two hydrogen isotopes, deuterium, into a helium. This fusion of elements creates even more energy and therefore more heat to vaporize the water, and there's no chance of any meltdown at all, not even a theoretical one. Fusion plants also produce waste in the form of helium gas, which is useful in electronics and other consumer products. Fusion is still on the horizon, however, as scientists struggle to replicate the ideal conditions for nuclear fusion. Nuclear fusion requires deuterium to turn into a plasma, which is extremely complex and hard to contain. And even worse, reaching the temperatures that cause fusion for a prolonged period of time simply are not possible with current technology. The plasma is so hot that it needs to be levitated in midair to avoid coming into contact with its container. This requires extremely powerful magnets and shielding that are simply not available yet. So when nuclear fusion power plants are on the horizon, we are not quite there yet. That does not mean we shouldn't focus on fusion for the future, as it will be much cleaner and much more efficient than any type of energy we have available today. It will also be cheaper and much easier to maintain than anything we have available today.